Hey guys, welcome to GME 162 Spring 2025. I will be your instructor online this term. My name is Orlando. If you've met me already, you know that I work full time. So this spring term, they needed another emergency instructor. And so here I am. The best I could do was online, being that spring through fall is probably our busiest time of the year, especially the summertime. Luckily, we don't have to do any. Uh, Luckily, you guys have a break through there, so we don't have to worry about that. So for the next 10 weeks, I'm gonna try my best, just to keep you guys in line with GME 162. We'll start off today just a simple introduction to again, kind of like we did 161, simple introduction to everything. And then we will continue from there. As for the course itself, we're going to just pick up straight with digital level looping, or not digital, sorry, level looping, kind of like what we started with week 4 of 161. If you have any questions, you can always just reach out to me by email, but we'll get started with that here shortly. Let's see. So I will be the instructor for the online portion of it. The in lab, or the on campus lab, should I say, that will be Eben. I'm sure most of you guys know he is the OIT Geomatics president. So he will be your guys' instructor for the lab portion, and I mean, very capable guy, of course. I'm glad I have him. That way, he can help you guys along through everything. Let me see. Let me make this big again, and so we can know that you guys are getting some good labs in and good exercises and just good structure of how we want to give you this course week by week. All right. So first thing, like any other thing, we'll just go over all the small stuff, the intro to the class. So if you go to the module, or to the course itself on Canvas, I'm gonna go view a student here so you guys can see it like you, so I can look at it like you guys look at it. We're gonna have different modules, and so far what I have set up is I have the syllabus here under references. I have formulas for you guys. We have the campus control, which we're gonna need that for just starting out with lab 1. We have the field book, grading matrix. We have notes of examples. I have a lab manual from previous years that I have. You guys can take a look at it. And then we have the first level, or the first lab, there on the module underneath labs. So let's see. The first thing I want to go under is, let's take a look at the syllabus. Let's see if it'll load up. If not, I'll pull it up on the file explorer. We can do it that way. Doesn't want to pull up. I'll pull it up right now. Let's see. Should be under admin. There we go. All right. So, like I said, GME 162 Plane Surveying 2, spring of 2025. This is the Oregon Tech Geomatics Department. Again, my name is Orlando Aquino. I'll be your instructor, and I will not be on campus. Oh, sorry about that. That's my phone. Let me turn that on silent. I will not be on campus, so the best way to email me is through email. The best way to contact me is through email. Contact hours, I don't have any office hours. I believe you will have your labs on Tuesdays and Thursdays, 8 a.m. to 11 p.m. I could be wrong on that. And I didn't check the room, but actually we can look at it right now. Hang on. Let's just pull it up here. I believe it'll tell us if we just go to a course search on the website itself. And we go to the geomatics page here and see what it says here. It says Owens 130, and that is Tuesdays and Thursdays. Okay, so let me change that. I'm gonna have to re-upload it. So it'll be Owens 130 for both rooms, to meet. and then you guys will go to obviously to the 203 to get checkout equipment. All right, so let's just go over a few items of this on the syllabus and kind of just give you a rundown of 162. So the catalog description, we're gonna have digital theodolites and data collectors, instrument testing, observational error analysis, theory of leveling, solar observations and computations, EDMs, which is electronic distance measuring, use and calibration, field labs, including solar observations, traversing, leveling, horizontal curve layout, introduction to COGO software. So, kind of, it's a more, we're gonna hit the nitty gritty, the very meats and potatoes of land surveying, the basic stuff and what it contains. So we're gonna also get into the very technical side of note keeping and organization. So 161, the labs were pretty laid back. I would just give you the handout and you guys would just take, uh, your field, those notes or those questions, answer them and turn them in or whatever it is. We're going to require a little bit more than that this term because we're going to, there's a standard when it comes to this stuff. And the standard is there because the notes are very important because they can become legal binding documents in a court case. So those notes have to be organized. Those notes have to be clean. Those notes need to be well uh, well documented and neatly written as to other people can look at them and understand what is the intent, what was your procedure, what is the overall conclusion of your work. So prerequisite, again, 161 and math 112, or if the instructor consented to it. The required text, it is going to be Elementary Surveying 15th edition. And hang on, let me pull up my video so you guys can see my face. I'm holding up the book here. Hang on. Video, there it is. Elementary Surveying by Mr. Charles. It's a Pearson book, but again, it is the, can you see that? 15th edition right there. So the 15th edition is what we will be using and what we'll be going through. You can find those at, online. I think the Oregon Tech campus does have those, I believe, for an outrageous price. So if you can find it somewhere else, go ahead. All right. So required supplies, we have the Casio FX991 calculator, the HP35s. Those are the money calculators. They're gone. I mean, they might be in production. I think Anthony was telling me last term that they were trying to come back with them, but otherwise you're paying like $200 to $300 for the ones like on eBay or ones you can find out there. So, I mean, if you can find one, great. If you, otherwise, going to try to go with a different brand that kind of does reverse Polis notation is the style of those calculators. Let's see. Well, a lot of these other things you should already have. Let's see, Paga tape. Those are in the equipment room. The tool belt, I believe we have those. If you want to get a vest, pick up a vest. I mean, they're not the cheapest, but if you want to pick up a vest, safety vest, highlight safety vest, that's not required. What I am going to require is the engineering computation paper that is required, the engineer scale. If you don't already have one, you should already had gotten one. This is going to be required, the surveying field notebook, and those you can pick those up at the Oregon Tech library. And let's just do a quick Google search here. The land surveying field book, yep. Those are kind of the ones. There's one that's called Ride in Rain or something like that. I personally have this one here, this Sokia Field Transit one, but these ones are going to be, what is this thing doing? Never mind. Let's go back. Let's just hit images here. Images. Yeah, but they're going to have these style of pages. So your sketch would be, your notes would be on this side, like your math, your computations, everything that you're doing. and your sketches are going to be on this side. All right, so let's go back to the syllabus. We'll get more into that field book here in a little bit. So again, and appropriate field clothing. So again, you guys are going to be working out in the field 2 days a week. And right now, the weather is looking kind of crappy. So I advise you to pay attention to the weather as much as you can. I know some of you kids are kids and don't have a heck of a lot of money, but if you can find decent boots, clothing obviously is a little better, easier to grab. But like as you can see, we're gonna have a high of 45 and we're gonna have 90% chance of snow that day. It says less than a half an inch. So that's great, but it's still going to be wet out there. And then Thursday, it's going to be a partly cloudy day, but it's going to be only a high of 49. And again, you guys, you see this high at 45. That's great, but that's not till 1 or 2 or 3 o'clock in the afternoon. You guys are going to be out there at 8 in the morning, 8, 9, 10, 11 in the morning. So again, make sure you are wearing the appropriate clothing for the field. So, the mission department mission statement. The geomatics department degree options are designed to prepare students for successful careers. This is achieved through a combination of education and training. Students must develop the critical thinking skills when prepared them for the long life learning in ever-changing geospatial disciplines. The ability to read, discuss, research, analyze, and work independently embodies essential skills which are the heart of education. Training in the use of modern geospatial tools is also important to produce job-ready graduates. However, it is your education which facilitates a successful professional career, not training. So, I mean, there's that saying: give a person a fish, they eat today, but if you teach a person how to fish, they eat forever. Jack Walker's strongest philosophy, and he always mentioned this, is we play with all these fancy toys and all these equipment, and then all of a sudden, you're walk to a construction site, and there's these guys that are out there too, the excavator guys or the concrete guys, and they got their own fancy S7s, total stations, GPSs, but they never trained on it. They never had formal training. They never worked with it in the field and got to train as they were going along with it. So what they end up becoming is button pushers. So that's all they do. They just push the buttons because these are the buttons they know how to push. These are the buttons that know how to cut and paste to that job or get to that job file, open that job file, go to that line work and take a shot there. And they can say, oh, look at that. I'm within, a hundredth by a hundredth on this line. But they don't know how to set up that they don't know how to do the field work to set up the whole control network, to run a traverse, to run a level loop, to run the data collector, to upload, download that job file, to manipulate the data how it needs to be, to understand what are the fixed points on a traverse and why they are so important. Just kind of like what you guys did in that fall term, right? What was the whole point? The whole point of GME 161 was traversing, right? Was to run a traverse. That was the whole point of that whole lab or that whole term. I mean, we gave you guys level looping, of course. We gave you guys, understanding how to do small things like pacing, understand how to do navigating the compass, pulling tape, all those easy developmental things. But the actual big thing was, how does a traverse and a compass rule adjustment work, right? This is what we need to understand as a department, or for as students, that this department emphasizes that total station is not just a black box, right? It doesn't, we just don't spit in numbers in there and it spits you something out. There's a way you want to understand it, and there's a training to this whole thing. And the way we as Oregon Tech alumni and current instructors or professors, what have you, that is the biggest effect that we've had, in career fields, is like when our students graduate, via working with their hands during the term, but also getting those summer jobs, working the summer, working your butt off, hiking, whatever you're doing, staking, slamming hubs, setting rebar, all that stuff that you guys are doing during the summer, those 3 months, they're a tremendous amount of help. So if you guys are in that position, where you can go get a job during the summer, right? You have the flexibility to leave Klamath Falls, and maybe you're staying up in, wherever your hometown is. You can stay with your parents, or you can stay with a roommate, and it's, much cheaper to do that. And you can make quite a bit of money while you're understanding how surveying works, not just in the theoretical side, not just in the desk side of it, but the actual field work of it is so much valuable. You become so much more valuable to an employer or to yourself if you want to become your own employer later on, right? So this is what we need to understand as students, that we're trying to like drill into you guys. All right. So the development provision of using field survey equipment, including this total station and the automatic levels, which this is what we will hammer you guys on the total stations. Development of proficiency manually recorded data in your field book. Again, we are going to be neat. We're going to be effective. We're going to be well documented in our field books. We're going to give you plenty of examples to go walk through. Quizzes we'll use to reinforce topics of the class, not if of the class. Let's change that. There will be no makeup options for quizzes unless prearranged. The quizzes, though, will be available on Canvas all term, right? I'm going to give them out a certain day, but they will be available for camp throughout on Canvas the entire term. So if something happens, I had like one student last year, or not last year, last term, he got some medical issues going on, and he reached out and was like, blah, blah, blah. It's like, well, hey, it's there. Everything's there. Everything's ready. I mean, it's not going to change. Nothing changes because, I mean, especially for the online students, you guys have, real life going on, because there's a reason you couldn't be on campus. Is because either you're working full time as well as survey interns, LSITs maybe, or advanced survey and training, or you're in a position that you can't afford to move all the way to this side of the country if you're on the other side or wherever you are, and physically be here and pay all the god amount of money that it takes to just go to college. So yeah, I totally understand when it comes to that side. My biggest objective is, as long as you're understanding and learning something out of this class, then we are helping you somehow. That's what I gather. I'm not a hard ass when it comes to this stuff, because I myself am in that position where I'm working 50 to 60 hours at most times, and then at the same time I coach my kids soccer. I have a wife. I have my other family that needs help. So, I'm not really sitting down and waiting around, trying, seeing how I can torture you guys um, on, due dates of quizzes or homework. That's not what I do. The final exam, there would be a 2 hour final exam that will be held in accordance with the university final schedule. So I believe this class was to meet Mondays and Wednesdays, and I can double check that, and then I can set. But again, I will set up the final exam to be on Canvas for you guys. So it'll probably be just uploaded the week of finals, and you guys just turn it in that last day of finals for me, whatever that Thursday of June, whatever that is. Grading policy. I might drop down the homeworks maybe down to 3, but maybe if I can do 4 or 5, I'll try to. But yeah, we're going to have homework. We're going to have one midterm. We'll have quizzes, the lab projects, how well that field book is in shape, the lab practical, right? And then the final exam. Any incompletes, again, you guys need to reach out. If you guys are having some kind of issues, reach out to me. All right. Incompletes are incompletes if they don't get done at the end of the term. All right. I hold off as much as I can to give you guys a 0 until, it's that very, that Friday, after the term is over, after the finals are over, and I'm sitting there waiting, or Saturday, waiting for somebody to give me something. And if it doesn't come in, that's where it becomes incomplete. All right. So again, assignments will be submitted on that engineering paper on Canvas, right? So everything I want done on engineering paper, and then submit it to Canvas. So just upload everything to Canvas. And what I'll do on Canvas, because I can believe, let me see here, this one. So let me leave the modules here. Oh, there it is. I'm gonna leave student view. I will create an assignment for the homeworks and the midterm and the final there. I'll create it and then just you could just upload it to there. Everything though will be available through the modules. So like the lab is available there. I'll make a homework. Yeah, there's a homework one, there's a quiz, there's an exam one already. I'll upload everything there. You can download everything there, and then you can just turn everything in through the assignments. All right. Let's see. Again, field books are required to meet closure specifications. If your requirements are not met, the field book must be repeat or field lab must be repeated. Sorry, field labs. I'm sorry. I'm over here dyslexic. Field labs are required to meet closure specifications. Again, you're not going to go to a job site, run a traverse, and go, oh man, I closed one in 2000s. Like that's a horrible closure. We got to redo that thing, right? We're not just going to let that be okay and just move on with our day. Like we have to redo that because we need to be within one in 10,000s minimum. Same thing with, if we have vertical tolerances, if we don't meet that class 3 minimum, then we got to redo our level loop, right? So this is why, again, we have 2 day, two labs 2 days a week. So that way you guys can get into that mindset that once you start a project, it has to be done to a certain standard, no matter what, right? We have a standard, we have to finish it to that standard. The standard doesn't go back or forth. The standard is the standard, plain and simple. So again, the material part or the distance education is well, that's going to be from everybody, right? You guys, I'm gonna have, I'm gonna have a whiteboard to run through all the stuff. I'm not going to give any type of lecture on anything today. We're just going over everything. But again, everything's going to be available for you guys. I believe what I'm going to do so it's available at all times because what I was running into last term was a data issue or data storage issue on Canvas. So what I'm going to do this term is create a YouTube channel, and then that YouTube channel will just have all these videos uploaded there, and then you guys can access them at any point, anytime, and then they're right there for you guys to look at. All right. So let's see here. Lecture notes will be submitted each Friday in a PDF format during the term. That I might not be able to do. That part may be the hard part for me to do. Everything, though, I mean, I will record, I will upload, and it will be there. And I will have a lot of different PDF references for you guys, just kind of like what I have already. And that way you guys can go from there. All right. So exams, the midterm exam and final exam are scheduled. I have them already kind of booked up already for the weeks, when they're going to come out. I'll give you guys a fair warning when those are ready. But again, the final exam is just the final exam. So the midterm exam and the final are closed book. So this part is you're going to have a formula sheet, right? And then we're going to review. We'll definitely review for both. And again, we will make sure that you guys have enough time to get the awareness that the midterm is coming up, right? That it's going to be here, it's going to show up. You guys have time. And I do expect you guys to, use the honor system and just use your notes that are, because they'll give you sorry, not notes, give you the formula, use the formula sheets provided, right? And those formula sheets are what going to get you through the test. Again, is that what's going to happen in the real world? Are you going to, you're going to have zero references to go off of? No, of course not. But the thing is, that philosophy or the mission statement, giving you guys that hands-on training, understand what you're doing. At the same time, if you guys want to become licensed surveyors, you have to go through the NCEES, testing standards, and those are closed books, right? The FS and the PS are completely closed books, and you guys have to make sure that you are understand the formulas, you understand how to get to those formulas, you understand how to use your calculator very well, and you understand how to manage your time while you're doing that test. So this is kind of one of those reasons why we're making it a closed book exam and just giving you formula sheets. So classroom etiquette, not much classroom etiquette because we don't have a classroom, right? I just left it in there from last time, but we'll skip that. the academic integrity. This goes back to that closed book stuff. Again, when especially the quizzes, or not the quizzes, the exams. Uh, I mean, let's not don't try to make me second guess if you had any cheating or plagiarism going on there, because I don't like dealing with that stuff. It's I don't have time for it, so you know that's the one thing that I don't really want to be dealing with. All right. Again, if you have any type of disabilities or anything like that, reach out discreetly. You can always just reach out and let me know that you need something, some type of accommodation, and more than happy to help you there. Classroom content. Let's see. Again, we're not going to be really together except for the on-campus students, but you guys get along pretty well, so you guys will be okay there. All right, let's get down to the outline. All right. So the course outline, again, we're going through the syllabus. We're going to go through just helpful. We're going to go through the survey profession. We'll probably do that on the next lecture. Okay. The calculators, Excel, and other resources. All right. That'll be part of that. Chapter 2 will be leveling. Then we'll go to measuring distance. Then we'll go to traversing. Then we'll hit the computing area, astronomic observation, instrument and equipment adjustment and maintenance, topographic mapping, a horizontal curve layout. And I don't know how we're going to do the drone one. That's going to be a tough one for me. I don't know if I can get a hand on I mean, if we can just go through the theory, the great. Otherwise, the actual lab side, that's going to be another cheap. And then GPS basics, we'll go through that for sure. All right. And then here are going to be some of the here would be the lab projects. We'll start out with differential leveling, and then we'll move on to profile map and plotting and Stadia introduction. Then we'll go to EDM, or electronic distance measurement. Then we have traverse computation and distance reduction. Then we have determining height of a remote object. Again, that drone flight part, that's going to be tough. I don't know if we can get there. I know Evan said he wants to do a solar observation, so we're going to probably try to keep that one in there and try to get one in there, at least one solar observation. Topographic survey, the traditional methods, and then the manual way, and then maybe if we can do it with Carlson. And then we have GNSS surveying, again, if we have time, and then intro to data collectors if we have time. All right, so there is our class syllabus. Let's move on to that field book. All right. Let's see here. We have, okay, campus control, we'll go over that, but that'll be part of the lab. Here we go. Lab examples, GME 162 grading matrix. And that's going to be, I had it down here. The grading matrix. All right, how are we going to do this guy? All right, so the first thing that we want to show is on that field book. Let me pull up that image. Where was that image at? I believe, let me pull up this guy too. I believe we have this guy too, the manual. Yep. So this is something that we used to have the students get when we were taking the course. So this was GME 161. Yeah, this is the lab manual for GME 61. But we also had the standard of how we wanted the homework assignment and two, the lab handout. So this is the homework assignment. We'll go back to that. Anyways, the format part. I want something like this. Let me turn that like that. It's not going to let me turn. All right. So just tilt your head to 90. All right. But again, right at the front of the page, you open your field book up, and that first page, it's got something like this, that left side, and then the right side there. Let's see if we can look at it. Something like that, right? Well, in your field book, that first page on that right-hand side, I want the page number of where it starts, right? I want the lab manual, which lab number it is. I want the description, what it was, and then the grade. You don't, I mean, you can put grade, but you don't have to fill that part in. I just want these first three. And again, I want you to label it up here index. Okay. And then let's see, let's go back to the grading metrics. So again, did you complete the index page? Is the index page completed? So when you turn these in, when you do these at the end of the term, right? When it's all done, do you have go through these and make sure you have these done? All right. So again, is the index page completed completely? You know, do you have all your labs in there laid out as you need to? The title page completed. Each one of these labs is going to have a title page. You're going to have the date, and I'll show you an example of what I'm looking for. You're going to have the crew, the names and assignment, what they all did, the title of the project, the weather, equipment that you used, and indicated if it's a copy or if it, you know, if it's original, you don't write copy, you just leave it as such. But if it is, you copied it from your field bookkeeper of that week, put copy on there because you needed to copy all the notes, right? Yourself. Because everybody, again, even though you will have a crew, especially my on-campus students, not my online students, you guys will actually be by yourselves, or maybe you have a rod man or an iron man with you. You will have a crew, and that crew that you have will be your crew for the term. So whoever you got in there, I know there's only 10 of us, I believe, in the entire, you know, between all of you guys. So who's ever there in lab, just whoever you pick for your crew members, that's your crew for the term. So again, you guys will be switching roles between party chief, the rod man, no keeper, you know, all those things. You guys will be switching, and then so the no keeper will always be the original, right, of that week, and everybody else is just going to write down the exact same stuff, everything the same. It's just going to say copy, you know, on one of those in that titles page. All right. And then data organization. Did you follow proper format for the lab manual example? And again, I'll try to give you those to follow. Field sketches. Do I have field sketches? Do I have like a north arrow? Do I have descriptions? If you have stations, all right. Neatness, clear and legible hand printing, hard lead pencil or fine tip ball pen, right? Complete data recorded. Straight edges used if you can when you're trying to make sketches. No erasing. That's number one. Do not erase, because if you erase, it smudges everything. Those field books or that paper is not meant to be erased on. It's meant to just keep the data as it's written. If you do make a mistake, if something does, you know, if you make a mistake, let me pull up the example here that I have for you guys. I have an example there, but I'll pull it up here on my. Do I have it here? Give me 1 second. Let me find it. I believe I have it under the labs. And field note example. Okay. So let's say, you know, you wrote something in your notes as you're writing it. Like as such right here. This is a mistake. This piece right here, right? They made a mistake on their foresight writing. They actually put in the wrong thing. And all they did was do a simple slash through the mistake. 1 slash. That's it. And then they wrote the correct number above it, right? That's all they did. So that is what we're looking for when it comes to that, the neatness part. All right. And again, complete accurate field data. Do you have all the data completed? Precision of observations, accuracy of the observations, error of closure indicated, adjusted, or computed volumes in red. So that part, like when we run through a level loop, you're going to have your original data, right? You're going to have your elevations that you compute as you're going through. And then once you close that minimum class 3, whatever we require, then you're going to go through, run through your computations, and then input the adjusted in red. Okay. And I'll show you that here in a second. So again, this is an example of the differential leveling in peg test. So as you can see, the only thing that we blocked out was the students' names just for their privacy. But again, this was done in March 30th of 2021, right at the start of spring term. And again, this icon here is the survey. So this was the party chief, right? This icon here, they were probably the field note keeper or the I man, one of the two. And as you notice up here, the top right corner, this is the page number. So on the top right corner, as you flip through every page, you're going to put it on the top right corner, your page number. So that's page 1. The next one's page 2. Like, as you can see here, this is all page 2, the whole thing, right? This whole thing is page 2, right? So again, you'll see the title, the location, then we have the weather, then we have the equipment that they used, right? So right here, they put down this is a copy. So here's a setup for differential leveling, right? You have your station like we did in GME 161, backsite, HI, foresight, elevation, and adjusted elevation. These guys did not do the adjusted elevation, which they should have, but they did not. All right. All right. So then the next thing they did was they put in descriptions of their monuments, right? They got Ager, Melva, Duryea, and then they did some other standby features. And then they put in other descriptions on this side, page 3, and then this is their script or their sketches right there. As you can see, they continued on. What you are going to do first is the peg test, and then you're going to do your level loop, right? These guys did put their notes in the reverse order. I'm going to say I'm 99% confident that these guys did their peg test first to calibrate the instrument. Then they went through their level loop and got those notes done. All right. So there is that example. What else? What's the next thing I want to discuss? So let's go through. Let's see. I want to see. That is that for now. I'm going to pull up just a slideshow, and this is an old slideshow, but it has very relevant things to, because a lot of things, the more things change, the more things stay the same type of deal. So let's just go let's go over let's just go to introduction of the geomatics profession. This was our old professor, Professor Duryea. He had a great sense of humor. This was one of his little favorite restaurants that he used to go to when he used to live down in when he lives in the Spokane area. But it is Professor Duryea, and this was in spring 2014, 11 years ago. How crazy is that? 11 years for me, that's the year I graduated from OIT. So this was his last year that he was there. So again, his favorite quote: surveying is a science, technology, and art of making the measurements necessary to determine the relative position of points on and below the surface of the earth or to establish its points. Believe it or not, this whole paragraph, he required us to remember line by line in each test that we took. Otherwise, we'd be deducted points. And this would be the very first question that we'd have to memorize and write it line by line, word by word, verbatim. Otherwise, we missed out on points. All right, so the geomatics profession. Geo, earth, matics, to measure. All right, that's what we are. We are earth measurers. For the most part, in my world, I deal with plane surveying a lot, but I also deal with geospatial because of GNSS. And in that regard, I don't do a lot with, I do a little bit with aerial photography. I don't do a lot with Geodesy. Sorry. I don't deal much in that side of the world. And I don't deal a lot with, I would say, remote sensing side of the world, other than aerial photography and some, laser, using some point cloud data or some type of photogrammetry in that much for that world. But it is there if you want to continue that path for your profession. Again, the geomatics profession, plane surveying for areas that are relatively small, the curvature of the earth is generally ignored. Again, that's just your typical, small shift area. Geodesy, again, the big overall picture, what is the entire world, what you're dealing with, of how you're establishing coordinate systems, right? How are you even coming up with these theories? Again, GPS, global position systems, just dealing with satellites in general, global navigation satellite systems, again, dealing with Russian satellites, European satellites, Chinese satellites, US satellites, Starlink, all that good stuff. Cartography and digital mapping. How good are you at drafting? GIS. How good are you at drafting with information? Hydrographic mapping. How are you good at doing rivers and creeks and maybe ponds and lakes? Remote sensing. Again, how good are you at doing any type of point cloud data that requires lots of infinite software of just thousands of points? Photogrammetry. How good are you at aerial mapping? Using getting on an airplane and taking photographs of those big white X's that you see on to establish, coordinates of air using aerial photography. And then we have land information systems, kind of like when you go on just a local GIS site, county site, and it has all kinds of tax lot information, all that good stuff. A lot of that stuff's not, boundary accurate. It just gives you a lot of information. Real property boundary location determination, that has to do with, again, drafting, subdivision mapping, platting, that has to do with property development. Cadastral survey, BLM. I think we have one student in BLM, right? I hope so. But again, cadastral surveying, that's a fun environment for me personally, because you get to just work out in the woods. You got to find old historic monuments that were originally set, back in the 18th century. Mining surveys, that is a whole other monster right there. I don't know much about mining survey other than that is a lot of different type of legal battles that go happen through there. Engineering and design surveys. You're the middleman between the contractor and the engineer. You're just translating what the engineer is trying to get accomplished for the contractor. That is a very, very tricky, not very tricky, sometimes tricky side of the construction surveying is understanding, the engineer, or maybe the engineer screwed up and you're trying to fix it on the fly, and that could get stressful, right? All right, the geomatics profession. You shall not move your neighbor's property mark, which the ancestors have set in your inheritance, which you inherit in the land that the Lord, your God, gives you to possess. Cursed is the man who moves his neighbor's boundary stone. Then all people should say amen. So again, this is the start, right? This is kind of the start. The ancient Egyptians used to use mark different lines with rope and rope and angles, right? Using different angles to do this. So this is the start of what we now call land surveyor or professional land surveyor. The geomatics profession, our national professional, or our professional organizations. We have the NSPS, National Society of Professional Surveyors, the state professionals. So we have the PLSO, Professional Land Surveyors of Oregon. Washington has their own. California, Nevada have their own. Then we have the American Society of Photography and Remote Sensing. I believe there's even a geodesy one. Don't quote me on that one. But again, so does the engineer side, right? Engineers have their American Society of Civil Engineering, I believe. So again, the mission statement strives to establish and further common interests, objectives, and political effort that would help bind the surveying profession into a unified body in the United States. You got to think about it in terms of historic ways. So the original 13 colonies, they don't have any public land surveying system. They never had any type of public land survey system because they were just colonies, right? They just started with, the land, and they started occupying it and writing deeds and all this stuff. And it just goes back to the colonial days. Whereas starting basically in Ohio and going west, except for Texas, they started doing these PLSS, these public land survey systems that at the time was the General Land Office administration to take over that, to start that. And then now it's under the care of the BLM, Bureau of Land Management. So it's hard, it's one of those things that we want to unify things, but just by laws, one from Washington to Idaho to Oregon, we have different laws and different ways of how, the surveying or property data or property cases are handled. So again, I mean, we are a unified body, but we have quite a bit of just a variety, state by state, agency by agency, of how we handle different problems when it comes to boundary stuff or surveying profession or any of that stuff. Membership open to all professional land surveyors and persons trained, registered, or interested in the profession of land surveying. Student membership are enrolled are available for enrolled in the geomatics program. So any of you guys that right now enrolled in the Oregon Tech geomatics program can apply for student membership as the NSPS. Same thing for the American Society for Remote Sensing. You guys can probably go on there and see if you guys can apply. But again, the mission of them is to advance knowledge and improve understanding of mapping sciences and promote the responsible applications of photogrammetry, remote sensing, GIS, and supported technologies. And then we have state associations. Again, we have PLSO right there, state of Oregon. We have Idaho. There is, I believe, Oklahoma, New Mexico down there, Nevada, ELSA, Washington, California, and then Hawaii. So we have different societies for different states, right? So your goal, I mean, especially that you are taking this you are in this program, is to become a licensed surveyor. That should be one of your goals, right? In your professional career is to become a licensed surveyor. So there's the basic steps, LSIT, right? Land survey and training, pass the FS, and you automatically, and you're automatically onto the next one, which becomes the PS, or the LS. We call it. It's now called the PS. And again, that's the principles of surveying. So you have FS, the fundamentals, PS, the principles, and then you have a state specific exam. So whatever state you're trying to get licensed in, you have to take the state specific exam for that state to get licensed in that state. All right. So that is the geomatics profession. Let's see, on to the next. Man, this thing is in the way. I guess you gotta minimize it. Hang on, let me make it smaller. All right, so on to, that'll be GME, the 161 lab, and that will be a different video. So I will make you guys a different video for the GME 161 lab 1 for the field notes. And that way you guys can get going on that. And I will show you guys what I'm looking for there. And then as well as just kind of going through the process again, just kind of a review of 161 when we